right, let's get this thing started. Grab your seats. Plenty of places to sit.
Well, that's the place you get the problem.
No one's going to sit in the front row. All right, cool. Well, welcome everyone. Welcome to Get Functional with Kubernetes. We're the Cloud Native Labs group. It's going to be a great session on Kubernetes, on serverless, some great speakers, some nice labs that we'll get into a little later. Special thanks to Emily and Alexandra for all their work to bring this together, and our partners here at Capital Factory. So, you know, Capital Factory has like a near and dear place in my heart. We about 4 years ago, I think it was, we were officing upstairs with Stack Engine, just me and the co-founders, Eric Anderson and Robert Gordon, and you know, with some funding, building a great team. Many of those guys are here from the Stack Engine crew, John and Karthik, and yeah, so excited that we're now part of Oracle. It's been about 2.5 years now, and we've had some great successes, and really excited about what's going on with the Austin ecosystem here. We've been doing a lot of work with the startup ecosystem internationally, and just recently we've launched a whole startup accelerator here in Austin, working with JD and his team. So I'm going to, with no further ado, let's give JD a quick intro, quick welcome, and we'll talk about what we're doing here, and we'll get into the session. So, JD.
All right. Welcome, everyone. Good evening. My name is JD Weinstein. I'm our head of startup ecosystem here in Austin, Texas. Quick show of hands here. How many folks do we have that are startup founders or employees in the room? Startup-y people? Cool. And then show of hands, anybody that potentially plans to start a company in the coming decade or so? All right, a couple more. Okay, now we're getting up. Great. So, you know, we've recently launched a new initiative with Oracle as part of the global Oracle startup ecosystem, and just opened up in the United States. And we actually chose strategically Austin to be that place, really close to our, you know, cloud hub and our cloud team. And there's quite some differentiation around, you know, most folks think about Oracle in the same sentence as startup doesn't really flow. Unless Oracle is buying a company, right? And so we're kind of disrupting that in that we want to bridge the gap between startup culture and enterprises, and unlock the channels that Oracle offers from enterprise customers, from interfacing with our solution teams, our product teams, our sales teams, and help startups really bridge the gap and sell faster and more efficiently in enterprise customers. In addition to that, the other piece and thesis of our program is really around Oracle Cloud Infrastructure. So Siva in the back over here, can you wave your hand? We're going to be choosing 5 startups in September coming up really to pilot this accelerator program. And Siva and myself, and then some ambassadors that we have around here, Suvia and Asif in the back, we'll actually be living in-house with the startups. Siva is going to be our technical mentor in residence, and so actually helping startups and other developers figure out and understand where does Oracle Cloud Infrastructure play in hand, and where does it make your business and infrastructure more effective and efficient. So we're right over here if you guys have any questions after that. Again, we're gonna kick off things in September. Our applications are open now, so if you have any interest around the program or what we're doing is really part of this new startup division, give us a shout. We have some of the coolest swag to keep you cool. These are fans that plug into your phones. So, quick side note. Anyway, thanks again, Bob, Emily, and Alexander, wherever you are, for putting this on. We'll get the show on the road.
So we have some great sessions coming up here. Really excited by those. We have Karthik and TJ. We'll be running those just a second here. Karthik, who I think many of you know, Karthik Gaikwad, is going to be focusing on Kubernetes and Kubernetes applications in action. Some good demos and some good technical discussions related to that. So Karthik has been part of the Stack Engine team, part of the whole ecosystem here in Austin. Cloud Austin, DevOps Days. You guys probably know him very well. And I'm super excited about the session coming up here. So I'm going to get Karthik up on stage here, get you going, and let's get this show on the road.
Cool, thanks a lot. Hey everyone. Let's plug this stuff in and watch it not work. Start screen record. Actually, is just mirror everything I'm doing, make it a lot easier. Arrangement, mirror displays. Sweet, awesome. Recording stopped. No, keep recording. Close. Delete. Sorry, folks. Squeeze recording. Let's go. And great. So welcome. I'm going to be talking about Kube apps in action. So after I pitched this talk, I realized that Bitnami has a thing called Kube apps, but that's Kube apps one word, and my thing is Kube space apps, which is 2 words. A little bit different, but actually, did anyone come here because they wanted to hear about the Bitnami Kube apps thing? Show of hands. Okay, good. I'm in a good space. One thing about Kubernetes in general is like everything kind of moves super fast. I was asked to put the safe harbor thing. Back when I was a startup guy, I didn't have to put up safe harbor stuff, but I work for the largest startup in the universe, namely Oracle, and this is something we put up. So I actually just started a new gig inside of Oracle. I used to work on the Oracle Kubernetes engine platform and product, but I've become a lot of people like ask me questions with just Kubernetes, and I have a course on lynda.com about just intro to Kubernetes and stuff like that. So I field a lot of questions, and then I was like, well, maybe I should just be talking about it a lot more. I'm iteration1 on Twitter, and then if you want to read some of the stuff I write, it's on blogs.oracle.com cloud native. So one question I have for you, because I think this will help me frame my discussion a lot more, is like, how many folks, show of hands, have used Kubernetes before? Good number of folks. How many folks use it in production? Good number of folks as well. Awesome. And then what about Java? That's a good number of folks. Cool. The reason I ask is like I'm kind of put together a demo that starts off with like a simple Spring application, and then we build on top of it. So today we're going to build. We're not going to build. I already have an application built out. It's in GitHub. You guys can check it out later. But we're going to like deploy it on Oracle Kubernetes Engine, and then take a look at one of the biggest questions I get is if you have a Kubernetes service, like what are different kinds of services out there. So we'll talk a little bit more about ingress and how to kind of do that. Then we'll talk about some Prometheus stuff, and if you have time, we'll talk about Jaeger as well. So let's close this out, and we'll go straight into demo world. It's a little bigger. Away. Second tab. So I basically have this like little app that I wrote. Nothing too crazy. Just a demo, and in here there is some code, source. So this is a Java application. I don't know. A little bit bigger. Not too big. Okay, cool. We have a demo here, and it just has a controller and a little like demo app. But basically, this is for folks that have done Java stuff. This is a Spring app. It responds to the slash, and then whenever you hit it, it'll just say greetings from Spring Boot. A lot of rocket science that goes behind it. Just kidding, not kidding. And yeah, some logging stuff in here. So I'm gonna kind of like build on this thing as we go along. So let's go back. to make this a little bit smaller. All right. So the first thing we're going to do is actually we're going to take a look. We're going to deploy this application into Oracle Kubernetes engine. So that's kind of like the Oracle. If you guys have heard of like AKS or the Kubernetes distro from Azure Cloud or whatever, this is Oracle's Kubernetes engine. So has anyone actually used OCI before? Quick question. A few folks. Okay. So in there, we recently, I think like last week or so. So funny story. I went on paternity leave, came back, and like everything looked different. But I think like last week we changed the UI a little bit. So on container cluster, I'll have to restart. Session expired. Okay. Make sure my canon stuff is still good. All right, we're still good. Okay, so this is the clusters tab in OCI or OKE. I have a cluster that I already created. We have a concept called node pools, and if you used Kubernetes before, Kubernetes is like the orchestration engine, and it runs on specific nodes. Different platforms call this different things. Inside of OCI, we call it a node pool. And in here, we have like 3 different instances that we're running. There's also like a work request tab that kind of gives you more information when you're like building your Kubernetes engine. And there's a getting started section where I think you get dropped into this if you don't have anything up front. So like if you don't have a cluster, you get dropped into it. You'll also notice up here there's something called upgrade available. This is because I've started a 197 cluster, but if I want to go like Kubernetes releases like every 3 months, so it's kind of sometimes hard to keep up, but we have this thing where we kind of keep up with the version, and so if you want to go from like one cluster, like 1.9 to 110 or 110 to 111, you can do that. That's a feature thing. So we'll close that, and we'll actually go into a shell window. And make this all kind of bigger. So let's do a kubectl, actually, here. So we'll do a kubectl get nodes, verify that I can actually talk to my Kubernetes engine. Maybe make this a little bit bigger. Is that visible from the back for folks? Okay, cool. I always hated when like you do a demo and you're like, I can't see anything. What? Okay, so like we saw in the UI, 3-node cluster. We're gonna do like a kubectl get pods. I don't remember if I've deleted everything. Okay, good. So I have deleted stuff. So that's great. What I'm gonna do is I'm gonna take that Java application that I had. I've already containerized it, and I'm gonna deploy it into this Kubernetes engine. So I'm going to run this kubectl apply -self deployment. But before I do that, let's just take a quick look at the actual deployment. So all of this stuff is in GitHub already, so you can kind of get to it. But for the folks that are not familiar with Kubernetes already, Kubernetes is there's like a whole language construct to it, but a lot of it kind of flows with deployments and services. And so deployments basically kind of say is the thing you're going to go run. So in here I have like a container that I've built out. So that's the Cartesian Java demo container. It runs on port 8181. And then once you have that built out, then you have service associated with it. And the service is the thing that you actually kind of talk to. So when you type in the web browser, type in your URL or whatever, you're hitting that service. So in this case, it's running on port 8181, but I'm going to expose it on the node as 32,000. So let's go ahead and do a kubectl. Actually, I'll just pull it from here. This will make it a lot easier for me. Apply. So run that guy. This basically says your deployment Java demo was created, your service Java demo was created. Looks good. Let's make sure that this is actually doing what it's supposed to. Get all. And we'll notice, for the folks that have done Kubernetes stuff before, this is like pretty common, but for the folks that haven't, you'll notice that there's like 3 sections. One is the pod, one is the service, and then the other is the deployment section. The 2 most important things and we also have a result set section, but the 2 most important things to look at here is making sure that your deployment has a desired and current state of world 1 and it's available. And then also making sure that your actual, what's that called? Your actual service is up and running as well. So I've declared this as a node port. So if I do a kubectl get nodes, I'm going to pick one of these arbitrarily, so 234, and we have the node port of 32,000. So if I go into my web browser, in fact, I'm going to make this, and pull this out. $32,000. This just gives me my greetings from Spring Boot or whatever my application that I had built out. It just throws out the output to it. So basically, what have we done? So we've taken the app that we typically build out. How many folks are developers in the audience? And DevOps? Okay. So what about like product management or QA? Okay. So typically, like all of us kind of work in large teams, right? Developers are like churning out code. Product management is like kind of building the agenda for what product's going to be. DevOps teams are working with developers to kind of like build out the architecture and making sure that systems are stable. QA kind of helps with that a lot of the stuff. So in the cloud native scheme of things, containers is like kind of sits in between because developers can still churn out their code. DevOps can help with making sure systems are stable by running containers, and Kubernetes kind of plays a role in that middle of that ecosystem where it's where people are kind of collaborating together. Because before, you'd have the proverbial wall. You just you write some code, and you either throw it to the test team or you throw it to the operations team, and there was a lot of friction between the different teams in an organization. So Kubernetes in general helps you kind of guide through all of that because DevOps kind of gets a platform where you can talk about, hey, here are things that these containers aren't working, and here's a reason to kind of push it back up the stack. So, long story short, we have a more managed way to kind of get out what we want to get out. So okay, so we have our simple application that we've deployed. And so let's add an ingress controller to this. And the reason I wanted to touch on this topic real quick was one thing that's kind of confusing to people is just the concept of Kubernetes services. There's at least 4 things you want to touch on. There's a cluster IP, there's a node port, load balancer, and there's ingress. And cluster IP on the Kubernetes, from a Kubernetes standpoint, it's where you have an application, you've exposed it, but it's not exposed to the outside world. It's only kind of sitting inside of your Kubernetes cluster. And the reason it's used is, you might have a authentication platform or something like that, where you're building out microservices, but you don't want, and it's a web service or something like that, but you don't want to expose that to an external customer. So it's kind of sitting in your thing. So that's where you use a cluster IP. Node port, like in the example that I used, I just had a cluster with many nodes on it, and it's just declared as a static port, something between 30,000 and 32,000. Load balancer is when you work on OCI or Amazon or something like that. When you use a load balancer service, it provisions a load balancer node for you. And ironically, if you look at the Kubernetes documentation, one of the easiest ways to expose your application is to use a node port. What's the not node port, is to use a load balancer. But what's the drawback from a consumer perspective to use a load balancer? Any guesses from anyone? What's up?
Maybe, I mean, this is a guess, but if it's you're exposing it all at one point, I would think if the demand is high enough, the load balancer can get overwhelmed if you have one of them. And additionally, if the load balancer goes down, you can't get to your service anymore.
Sure. Anyone else?
I think you're just going after the management. You're adding a moving node.
Okay. Anyone else want to take a guess? So one of the things, like, load balancers work great, right? Like, load balancers are meant to balance load. Kubernetes makes it really easy to create applications. Kubernetes makes it really easy to create load balancers. But their load balancers, from a platform perspective, have cost associated with them. So if you have like n applications that you deploy, you also have like n load balancers deployed as well. And from a provider perspective, it's great because like you're kind of using resources that the platform wants you to use. But a lot of times, you might not want to use like one more load balancer, or you might have service limits where you can only have like n number of load balancers that you can use. But if you start using a one load balancer per one application, you end up kind of running out of the quota, or also like increasing your bill. So that's kind of where ingress comes in. And ingress is basically, you can think of it as like a many to one. So you have like single load balancer, and you're trying to like fan out to different services behind the scene. So it's kind of like helps with the one-to-many relationship. So let's take a look and actually deploy an ingress controller for our application. So I'm going to use, has anyone heard of Heptio before? Heptio, a few folks? Yeah, Heptio is a company that's like doing a lot of, like, I think they're doing a lot of really cool things with Kubernetes in general. But they have this thing called Contour, and Contour is an ingress controller that works pretty well with Envoy, which is another kind of thing that helps you, build out like an ingress controller. So let's go ahead and deploy that. So they actually have a pretty cool script that you can just run. A lot of people don't like running the script just out of box because you don't really know. It's like doing a curl bash. You don't really know what's in there. But I'm in marketing now, so it's like a little bit okay doing that first time. Yeah, well, yes. In this case, but like I'm looking at this specific thing, and it's like, okay, we're creating a custom resource definition, a bunch of stuff for associated with the ingress routing. Actually, make this a little bit smaller because there's a lot of stuff in here. Deployment, so we'll take Contour. It'll run this in the Heptio Contour namespace. There's some stuff for Prometheus for it. And then, there's a cluster role binding, and more importantly, cluster roles, this is for the RBAC stuff, and the service, which is the thing that we actually care about for, how it's actually gets up and how it ends up getting deployed. So let's take a look. Looks like everything deployed well. kubectl get all minus n Heptio Contour. That's the namespace that it deployed in. And give it a little bit of time. So we'll notice that it has some pods, there's a service, and there's a deployment for it. And it has an external IP. So in this case, because we're using Oracle Kubernetes engine, it's actually deployed a load balancer behind the scenes for us. And then it's running on port 30188 and deployments and whatnot. So that's great, but how does this relate to our application? So we'll take an application that we have, and let's take a look at the actual code behind the scenes. So what I did was I built this like random application. I wanted to do it for the Java app that we just built out, but I ended up picking this instead because this had more endpoints. So in here, there's a deployment, there's something called wishlist, there's a catalog for it, there's a catalog for it, there's a wishlist portion of it, and there's also like an auth portion of it. So on 3 different ports, and also there's the services associated with that. There's the wishlist port, there's the auth port, and then there's the catalog port. And then the most important section in here is the actual ingress portion, which is, it says, okay, for path wish list, make sure it's connected to 8080. There's a /products portion that's connected to port 8081, and then the login portion, which is the login portion of it. So in theory, if this all works, like it'll be, you can hit the load balancer and then wish list, load balancer products, etc. And instead of typing out like a node port for each of these. So let's take that, apply it. So it'll take a couple of seconds. So this will create the deployment, service, and ingress. So kubectl get pods, make sure the pods are alive. Looks like they're running, that's great. kubectl get deployments. I have my Java demo that I just deployed. This guy looks online, okay, great. What about services? Looks good too. Okay, cool. So so earlier up here, we had seen, in fact, I'll just rerun it. Get all, close that out. So we have the external IP. We'll put that right here. And then we have products. And this just returns, product data associated, but it's running in front of the actual load balancer that the ingress controller created. So if I hit login, I haven't provided the credentials for it, so it gives back an invalid username, password, blah blah blah. So the content of what you see in the screen is not as important as the URL that we're seeing here. And this is basically doing you have one URL, so one IP, and then you have a login, you have a products, and you have a wish list, 3 things hanging off of there, versus doing a node port where you have an IP port, and then you're trying to change different ports on there. So ingress is kind of a way to do a one-to-many kind of relationship. So any questions so far? How am I doing on time? I think I have 10 more minutes to go. Questions? Okay, nope. All right, we'll carry on. So next, let's look at Prometheus real quick. At least I think we're looking at Prometheus. Yes. So Prometheus, how many folks have heard of Prometheus before? A lot. Awesome. So you don't need me to tell you that Prometheus is the thing that you use to kind of monitor Kubernetes. So for those folks that haven't done CNCF or Kubernetes before, a lot of folks use Prometheus as a way to kind of monitor the Kubernetes cluster, also monitor the applications. Pretty easy way to kind of deploy it. Helm has become the de facto way to kind of deploy applications in Kubernetes. So, it's actually now a CNCF project as well. But Helm is basically a package manager for Kubernetes. So, for people that have done, JavaScript or whatever, npm, it's something very similar in the Kubernetes space. You use Helm instead, and folks are kind of using Helm more. It's gotten a lot of traction since it came out. I think sometime last year. So, and as a result, there's also a Helm way to deploy this application, which is Kubernetes chart. It's called a Helm chart. So we can do a Helm install stable Prometheus, and we're going to deploy this guy. So this will take the stable Prometheus. So while it's doing that, we can take a look at what this actually is behind the scenes. It's a bunch of template stuff. You'll notice that there's a lot of crap going on back there. But Prometheus, there's a values YAML, which is the actual values that go in for the chart. And then there's a chart YAML. And this is the actual chart that Prometheus is kind of built on. So you'll notice that it has different components associated with it. And then if you look into the templates actually define all the different pieces of Prometheus that go into actually building out that entire stack of applications. So once this is completed, which looks like it has, let's do a Kubernetes get deployments. And I always kind of like do deployments first versus doing pods or whatever, because it's good to see like what's actually online. So we'll notice in this case the Prometheus server is not up, alert manager is not up either. So we can do a Kubernetes kubectl get pods to see what's going on. Looks like the alert manager is running, so this should be available, and then the server is doing an init right now. Looks like that's good. Verify the deployment's good, which it's almost, but you know what, by the time we do its services, and then I basically made this, oh actually maybe I did this wrong, because I think I typed in the wrong command. Sorry folks. Oh yeah, I didn't actually, this was the command I was supposed to copy. The nice thing about Helm is you can do a Helm delete -f. I did Helm install, I'm going to do Helm delete -f, or it's not -f, what is it? It's -purge. Oh. Yeah. I think it'll work with just, okay. Blah, blah, blah. Okay, minus name, and then open word. It's funny, when I created this demo, I was like, I shouldn't put this in there. There you go. Thank you. You guys passed the test. And once this deletes, feels like my laptop's gonna fall off the accordion. That would be an awesome demo. Okay. Work. Go. Now. Well, but it's running up there, so all right. There we go.
Take it so long.
Sorry. I'm not nervous, it's just really warm up here. So it's the reason I'm sweating, I promise you. Okay, so this thing will go do its thing. Named it prom demo. Alright, and then let's take a look at services again. So 30,001. I think this might take a little bit longer. Just to get pods on here. Verify that that server pod comes up. The Prometheus server, this is like the pod that has like all the juice in it. So that thing typically takes a little bit longer than all the others to come up. All right. We can either do that or we can do the crazy refresh on here a billion times. But all right, so this looks like it's an initialization state. So while that's coming up, basically the next thing that we'll see in here is we'll just kind of take a look at like the different Kubernetes statistics and stuff inside of the Prometheus server to kind of see why Prometheus is so important for all of this stuff. And then I have some more sections on kind of like looking at node information, and then also sending information from your application into Prometheus, so you can look at application statistics and stuff like that. But I think I might run out of time pretty soon. So you can just meet me afterwards and I can talk through that as well. Okay, everything's running. That's great. Let's look at this, 30,001. Maybe. Is my internet still good? Maybe. That was that. Okay. Notes. One random. Okay. Ready for you whenever you want to come out. I told my wife that when my son was born, because we're in the hospital a long time. Like, we're ready. Oh, there we go. Okay. Nice. All this time. So what were we actually trying to do? We were trying to look at some metrics in here, right? So we can take a look at the cube pod state phase, execute this. It might have come up to cube. Let's look at build info, because that's the sexiest thing we can look at, right? Let's just joke. Okay. So anyways, so there's some like random build information here. We can look at node info, node CPU total, for example. So you'll notice this is a little bit hard to kind of show on this screen just because Prometheus typically doesn't do a great job of, actually maybe it does full screen. I just learned something new. That's awesome. So this is like node CPU total information that we'll kind of want to look at. This is running on all of the different nodes that we have. And you'll notice the Prometheus chart, etc. So a lot of folks in the real world, Prometheus is good because it kind of gives you all the info and has a very basic UI. So a lot of times what folks will do is they'll take Prometheus, but they'll put Grafana in front of it. And Grafana helps you aggregate a lot more information up front. So you're not kind of like, toying around in this UI. The nice thing about, a couple nice things about Prometheus that you end up doing a lot more is Prometheus has operators. So we end up doing like, for our OKE service at Oracle, we end up doing like a sum of all the different nodes and things like that. So you can do, sum by whatever, whatever label. You can generate arbitrary labels for everything. So like we do sum by labels, and you can like kind of slice and dice your data. But then you end up using Grafana in front of it to, do something, to actually do your visualizations. So when the service goes down, whenever that is, people will actually like look at Grafana charts and like start freaking out. So if everyone's looking at Grafana charts, something's wrong. Something's horribly wrong. Cool. So any questions on this part, on Prometheus, or really anything else? I think I'm going to move on and give the stage to TJ. If folks do have questions on any of the stuff that we've talked about, Kubernetes or whatever, I'll be around. So feel free to find me. I'm also doing, for anyone who hasn't done a Kubernetes 101 kind of stuff before, we have a couple labs to do that and a serverless lab as well. So come find me, and thank you.
Awesome. Thanks, Karthik. All right, let's get TJ up here on the stage. TJ Fontaine is one of our lead developers. He's been with OCI, worked with cloud infrastructure a long time. He's got going to probably a little bit of history there, but also he was the lead Node.js contributor back at Joyent. So also all your Node.js questions.
Wow.
Don't disavow that anymore, but anyway.
You're going to steal all of the fun things I have on my slides.
Cool. Well, okay. So we're going to go into serverless on top of Kubernetes and everything around all those topics. And it's going to be a great presentation. I'll let you get it going. So thanks, TJ.
All right. Thank you. Let's see if we can get a screen recording. And then I'm going to do the slideshow, presenter view. Let's see. Hey, all right. Hello. You've seen this slide before. There's a different slide. It says my name on it. It says this thing, get functional. This slide says, safe harbor, don't believe anything I'm about to tell you, because Oracle wouldn't be happy if you believed me. Okay? Who am I? I'm TJ Fontaine. I'm a software engineer at Oracle for just over 3 years. As Bob mentioned, I feel like I'm ancient. I'm a grandfather in the OCI ecosystem. It didn't have a name when I started working on it. There were only 30 of us, and now there's too many to count. I started there working on the multi-tenant load balancing solution. Now I work across our container-related portfolio, the managed Kubernetes offering that you heard Karthik talk about, private container registry, and obviously I help talk with the teams about the functions as a service. And previously I worked at Joyent on Node.js. I'm not the TJ who is famous in that ecosystem. I'm a different TJ. I have famous in my own right. If there's something you like about Node.js, I wish I did it. It wasn't me. If it's something you didn't like, it's probably my fault. That basically sums it up. Please don't ask me about Node, unless you have a lot of time to hear me rant. So we're going to talk about getting functional with Kates, or since we're in Austin, I thought maybe we would just get a little funky. I don't know. Anybody else? Okay, fine. All right. So Karthik gave us a good intro about Kubernetes and Helm, and I want to kind of go into a bit more about serverless and functions as a service, and particularly as it relates to FN, the open source implementation that a lot of us work on. So serverless, for lack of a better word, is a cloud delivery model that people are kind of rallying around right now, and has in my opinion, a couple of principles that people care about. One, which is you don't want to have to think about infrastructure. And of course, we're probably going to come back to that point a lot. But in general, that means you're not responsible for turning it on or off, scaling it up or down, or monitoring. That's what we mean by don't think about the infrastructure. And then in general, you only pay for what you use, or to say, it's a consumption-based model. I don't know. Does anybody have a really strong understanding of how that's different from the cloud? Sounds like just what the cloud is. But anyway, yeah, it's different because we like to rename things. Or this time we really mean it. This time I promise, when we said we're only going to charge you for what you use, we really, really mean it. So that's kind of serverless. Functions as a service is a category inside of serverless focusing on compute, serverless compute. And it's tied to a specific kind of event, be it an HTTP request, kind of a queue, a platform integration event, something got put into your object storage, something like that. But instead of thinking of it as a compute instance with an operating system and your software deployed on top of that, you're just going to think of it as your software or your function, and that's your deployment units. That's the atomic unit that you're going around and passing, and that's going to get called when some event happens. So if you've got a functional programming background, you would be familiar with function is first class, or if you're in particular other languages, you might call it Lambda, not though I would ever suggest a different competitor or product. FN project, when we have the lead of FN here in the audience today, Chad Arimura, is an open source implementation of a function as a service that's container native, vendor neutral, and basically allows you, instead of having to learn a different tool set for how you deliver your functions to the platform, you can use your existing Docker tool chain and build processes to bring your functions to the platform. And then also it uses as the contract in and out of those functions, standard in, standard out, and standard air. So if you're familiar with the Unix paradigms, you're going to feel right at home in this ecosystem if you decide to kind of break apart RLE ecosystem and say, like, I want to get down and dirty with this functions platform. So really, what I want to talk about is a case study of what it would mean to deliver on top of Kubernetes a functions as a service product. So we're going to talk about how we leverage FAS in that ecosystem and what the world expects of us. So your customers, if you were asked to deliver this function as a service, they want to think of you as this black box, this magical thing where you provide them utility and they put in stuff, out comes out, garbage in, garbage out, maybe it's always perfect. But they put stuff in there, you do some work, and they never have to talk to you ever again, right? And of course, it scales. And not just scales, but it scales, to infinity and beyond, right? And this is what I could find on Flickr for Buzz Lightyear that was, free for me to put up. I don't know. But it's good, right? Like, so that's how your customer wants to think about you. Whether or not it's true or not is kind of secondary, right? So really, everything's about lives here, right? Like the cloud is just somebody else's computers. Serverless means we're responsible for managing the servers on somebody else's behalf. How are we going to deliver that? How are we going to deliver that, right? And your software that you're going to deliver is kind of broken down into different kind of components, but your customer doesn't care about that. They just want the product, and they don't think about how it all fits together. Just give me what I want. Here's my money. Give me the service, right? That's what they want to do. So that's a lot of servers and a lot of infrastructure for you to manage and to think about. And so what can we do to do that? We use Kubernetes to reduce the complexity by giving ourselves a different abstraction. But that just means somebody else who's running Kubernetes has to think about all those things you said. I don't want to hear about it anymore. That's somebody else's problem, right? So Yo-Dog, turtles all the way down. It's somebody else's problem. Unless I know there's a lot of you performing DevOps, it just means it's all your problem, and it's probably all your fault. But nobody else? Just like DevOps? Anyway, okay, fine. So now that we want to build and deploy a FAS on our Kubernetes ecosystem, how do we want to do it? Well, if it were me, I would want this black box that I just kind of put out there, and it also magically scaled infinitely, and I never had to think about it. Done. I can go home, right? That's it. So in practice, it's a little bit more complicated, right? Like, one does not simply launch a service, right? Okay, there's a little bit of life out there. Exciting. I don't know, I just got into this, I had this in my head, I was like, I have to, anyway, I think that's my last meme, you don't have to worry about it. So really, we have to think about all of the customer requirements and expectations about our service, and what it's going to mean to meet their needs, right? We're going to come up with they're going to say, here's our requirement, we want to invoke a function. I'm like, well, what does that mean to you? And like, how do you expect us to solve that problem? How often do you expect to be changing your function? How fast do you need your function to be invoked? Is this a synchronous kind of request? Is this asynchronous? We have to collect all that information from the customer, right? But before we can ever actually start deploying the service, we need to talk about fault domains and blast radius. And this also could be another turtle slide because things start getting crazy in here, right? So for lack of a better phrase, right now we're only going to concern ourselves with things on this planet. So if this globe that we're on right now disappears, I'm okay if the aliens are mad that our function as a service product isn't available, okay? I wish, how many people read Hacker News? Nobody? Fine, okay. Doesn't matter then. Moving on. All right, so fault domains, blast radius, that's what we have to concern ourselves in service delivery, right? It doesn't matter what you're building, you have to care about what happens when one of these things fails. If the globe fails, fine, whatever, but we're all gone. We don't have to worry about anything else. Multiple regions, if you're going to deploy your application in one region, there's probably multiple data centers. What happens if one of those data centers fail? All the way down to the process and the number of threads that are running. You have to concern yourself for your application delivery. What happens when any of these individual pieces fail? And then worse than that, your application, your process, that thread, that socket's connected to some other database or some other client, and what happens to that thing when you failed, right? Like, this is what you have to think about end to end when you just said, yeah, I'll give you a service delivery. Yeah, I got it. Don't worry, right? So this is how we have to think about these things. What happens when one of these pieces fail? So for the purposes of our function as a service product, we're going to consider only for the moment regional things. So if you're used to consuming in the public cloud, that's a metropolitan region with multiple data centers in it, all within millisecond latency of each other, right? But so we walk through all of that infrastructure that you have to concern yourself with of like, I have hypervisors with VMs on it, and then I have multiple processes running on it. How do I avoid the complexity of all of that but still leverage the notion that I'm trying to do? So Kubernetes allows you to do that by using affinity and anti-affinity. So imagine the wish list demo from Carthix had a replica set of 3, right? Like that web server was running 3 times. Great, I've scaled out, problem solved. Well, yes and no. If you don't actually say, I don't want all 3 of those processes to be running on the same compute instance, then you can run the risk of when that compute instance dies, all 3 instances of that will fail at the same time. So really, you need to be able to specify the boundaries of where your application can live, what can fail together, and what can't fail at the same time. So that's what we're talking about with fault domains and how we handle that. But also, another key component that I think everybody should keep in mind is that Kubernetes itself is a fault domain. What happens if you deploy your end-to-end application all inside of Kubernetes and then Kubernetes isn't available? Anybody? That's not rhetorical. What happens? That's right. That's right. So thank you. You get a t-shirt. So do we want one or more components, more Kubernetes clusters, just like we want one or more regions to deliver our application? We have to think about that, right? And one of the ways that we start to think about that as we pull this together, we say, okay, well, what are the components in my system? For a functions as a service product, we have a control plane. That's where people are defining their functions and their triggers and their relationships. And then we have a data plane where those functions are going to be invoked when those triggers come in, right? Should those be one cluster? Should they be 2? Should they even be in a cluster at all, right? Like, does it make sense for doing those things? What's the expectation for the availability of that control plane to your customer? What's the expectation for the availability of the data plane? What happens when one fails and the other doesn't fail, right? Like, what do you want to have happen? And so we have to think about how all of that fits together. And what our customer expectations are and what we are able to actually deliver for those customers. And since we're not actually building a stateless service, we should probably talk about persistence and what we need to do for storing the data that the customer asks us to actually invoke. So one option, we can have one data store, right? We can say, okay, great, I've got my control plane talking to this data store, and I've got my data plane reading from that data store, and then when customer says new function, data plane's ready to invoke it, problem done, I can go home. And then what happens if that data store is not available? Service is down, right? So, okay, great, then we'll have 2 data stores. And then, okay, well, now I can't actually have, my function being updated in the control plane and immediately being available in the data plane unless I perform some other complicated black magic voodoo. Okay, so fine, I'll sacrifice strong consistency for eventual consistency here. I'm going to play with my cat theorem. I'm going to pick availability instead of consistency, right? So all of these things are things that you have to consider when you're about to deploy a service and say, I'm going to be on call for this and I'm going to answer the page. How do you want to handle that, right? Also, I like Harry Potter. How many people like Harry Potter? Okay, sweet. Magic's not real, though. Can we all be on the same side? Okay. Oh, no, we got some questions out there. But, all right, so you may consume services from your cloud provider, and your cloud provider, I definitely don't work for one, just told you this thing's infinitely scalable, right? But I got to tell you, it's not infinitely scalable. The computers run out at some point in time, well, it's going to fail at some point in time, right? So if we just said, don't worry about it, I used my data store from my cloud provider, going home, checking out, it's okay. No, actually, while you're not responsible for the operations of that data store in the sky, you're responsible for the availability of it, right? Like, you may make a change to the schema, or one of your colleagues may make a change to that schema that adversely impacts. Somebody decides in the middle of the night to run a query. It wasn't prepped for that. It's not actually indexed. You're getting paged because you have the one data store, and your control plane and your data plane are down, right? So that's how we have to think about this, right? Like, it's always going to fail. When it fails, what do you want to answer to your boss when they said, why did it fail? And you're like, well, I only wanted to have to think about one of them, right? Like, so that's where we're starting from. Also, in this, we have to talk about multi-tenancy. What do we want to deliver for a customer in terms of isolation? When one function's running, and what's the expectation of another function, and when one's exploited? Do we expect it to be okay? If you're on-prem and you're running in your own environment and you know the application developers, maybe that's okay, maybe it's not, right? Like, do you need Is a container isolation enough? Is a virtual machine isolation required? Is bare metal required, right? Like, can you rationalize these things? What risk are you willing to take? Related on that side is the function execution. What's the expectation from the customer for how fast it's going to be before when the function is ready to invoke? Well, first off, we have to answer, what does it mean for the function to be ready? Like, okay, customer, you said I want to invoke that function. Well, how fast, right? Like, immediately after I declared it, I need to be able to invoke it. Well, okay, well, where you're using containers here, there's probably a Docker pool involved, so we're going to need to be a little bit more cautious, right? Like, so we've defined what it means to be ready. What does it mean to execute in that time frame? Can the customer wait for a virtual machine to be spun up? Can a customer wait for a pod to be scheduled inside your Kubernetes cluster? Or does it need to be faster than that, right? These are the kinds of questions, as you're defining these pieces together, what do we have to care about? So in the FN project that's available on the open source, you can start by consuming the Helm chart, and we have a demo area over here that you can come and stop by that kind of walks through, Helm chart plus Kubernetes to give you the demo. Some of the assumptions that we made for getting started quickly on Kubernetes was to say, okay, actually what matters a lot for FN is for the customer when they said, okay, I've defined that function and I want to go execute on it, I want that strong consistency. I want that API, I want to post to the API and immediately go try and invoke that. So when you look at the Helm chart, we have one data store, right? Like it's going to be a MySQL that's installed by a Helm chart, which I'll get into later. And then there's the API servers that are going to run, or the data plane that's going to run, which kind of handles both responsibilities of the API server and the data plane. That's because we want to be able to have these experiences for the customer. That's their expectation. That's not the only way that you can solve that, right? And then key here, we deploy this with a daemon set. So if you're new to Kubernetes, don't worry about this. Suffice it to say, we take control of launching the containers ourselves because that last mile is really important to us from a developer experience. What does the customer expect to be able to do when they type, invoke that function? I'm not the particular evangelist for FN, so Chad can give a mean FN demo. I'm going to misuse the words. So he's just going to like cringe in his seat a little bit. So we made that trade-off, that choice in picking the Helm chart such that it's easy to get started. But as part of that, right, like now you have to have these trade-offs that come with that, right? Like we have one data store, we require privileged containers so it can run Docker in Docker, and then that means that the Docker resource management is managed in a separate way from how the rest of Kubernetes does that. And we haven't answered if we need multi-tenant isolation. So you still have to answer that question in your own environment. But really, that's talking about the fact that you need to own this. At the end of the day, when you sign up for service delivery, it's on your shoulders to deliver that, right? What's strategic for you? What's not strategic for you? What controls your destiny? What should you be building versus what you should be buying, right? So in the FN example, we're saying that last mile of Docker execution is critical, and so we're going to own that experience instead of outsourcing it to Kubernetes to say, hey, that's how we're going to do it. And we can revisit that later, but in the meantime, this is what we expect from that software, from that system. Does that make sense so far? I mean, Garlic had demos. I'm just going to yell at you. Walls of text, fast, hand moving. It's crazy. So the other part of signing up for service delivery is how do I actually manage delivering the software, right? Like, so in Garlic's demos, you mentioned Helm. Helm is a package management. It's like lightweight templatation around all of the ridiculous YAML that you're going to be living inside of Kubernetes for a while, right? Like, you have to have something to describe these things, and the descriptions are pretty long. We need a way to handle not thinking about all of that. So Helm is our other abstraction, right? So, how do we handle doing all of this? Well, in the black box model of I want to just get started, I want to scale this thing, you want one chart, right? It's really easy for somebody to come in and get started and type Helm install, and then up it comes, right? But that may or may not be what you want, particularly if we've already separated our application between control plane and data plane. If we have a control plane piece and a data plane piece, do I want one Helm chart for both of those things? Well, if they're in different clusters, one Helm chart doesn't actually work in those environments. Right? I would need two Helm charts. and I would manage deployment separate from each of those things. Or maybe I break the black box up even further, and the control plane has many different components that all work in harmony together, so does the data plane, and those are even yet more charts inside of that. But you have to make those decisions for what's easiest for you from an operational standpoint to be able to go into production and provide that. But it's a balance between ease of use and uptime, which I was mentioning to Zach earlier. Of like, we don't talk about location because it's not real estate or data, but what we care about in service delivery is uptime, right? Like measuring our availability and what it means for customers, right? So on that, we need to talk about monitoring. Like, what is it that we actually care about? Also, how many people use averages when they're doing their telemetry? How many people say, like, half of all of my shit was working, half of it wasn't, right? Yeah, so don't do that. If there's one thing you walk away from, know that you have to at least use P90s or P95s, right? Ideally, you're going for P99. If you don't remember what that means, go get your statistics book back out. So monitoring of your service is more than just about the telemetry that's coming in, being scraped from your application from Prometheus. It's also about the logs that your service is generating, and it's about the canaries that you're running to be, the externally facing piece that comes and finds out before the customer is having a problem that you know that you're having a problem. Otherwise, why are we in this business? Like, why are we doing this if we're not actually testing our software? We can all go home. Like, I deployed it, it works. I didn't try it, but I know that the helm install completed. I can go home now, right? It's Friday. It's hot. I want a margarita. But to be careful, it's really fun to say like, ooh, I got this Prometheus thing, and I got my Grafana, and I slap them together. I'm going to shove everything inside of it. Well, as it turns out, we could do a whole nother talk on just how hard it is to deliver telemetry as a service for people, because given the wish list, everybody's going to be like, I'm going to give you everything. You scale, you figure it out, right? Well, if your pockets are deep enough, you can go do that, but otherwise you're going to have to pay for it some way or another. Either the telemetry platform is going to fall over for your usage of it, or you're going to lose all of your money for your startup, and you're going to have to go ask the Oracle Startup Accelerator for more money. So you have to make those things. So when you're thinking about what telemetry do I prioritize, you think about it in terms of what makes the customer happy, right? Like, think of the control plane, and the availability here of the control plane is reachability, and then also non-500s, right? Like, the customer is making progress. So we're focusing on how many errors customers are getting, and really that needs to be 0, not P99 of 1,000, right? So those are the kinds of things that we're trying to focus on. So be judicious in what you're picking for your telemetry and what you're using for your logs, so that you can actually find the answer when everything's bottoms up, right? Like, you can figure it out. Okay? All right. So while at Joyent, I had the pleasure of working with an internet famous person named Brendan Gregg, who, if you're a systems nerd like myself, is really into observability. So his whole thing, he wrote like 2 giant books on dtrace, and he works for Netflix now, and he produces content like crazy for Netflix about how to observe what's going on in the Linux kernel. He has this methodology called the use method, which U stands for utilization, S stands for saturation, and E stands for errors. And this is a method that he uses when approaching an individual computer, server, to figure out when it's having a performance problem, how to diagnose that performance problem. Well, a computer is a distributed machine. What we want to do, what I would suggest you do, is you read this webpage, because he's going to do a better job of explaining it than I will, and he's got videos and stuff about it. Take that methodology and apply it, right? Like, so figure out if your system, how long it's taking to service requests in your system, and that's going to measure very, very close what customer success and happiness is going to be. Figure out if you're queuing up a ton of work, and so you're saturating your data plane, or you're saturating the data pump from your control plane to your data plane, right? Like, figure out those things, and then obviously keep track of what errors are happening. You can break that down. You can apply that on each level for each component in your control plane and each component in your data plane, to think about how all of this fits together. So then we have to answer scaling. Now that I've given you a way to operationally run functions as a service on top of your Kubernetes ecosystem, on top of your Kubernetes cluster, what to do about the scaling thing, right? Like, I want to scale forever. Well, remember that there's no, if you're on-prem, I assume that you can't just keep, pulling in pallets and pallets of computers, though if you can, congratulations, and you're probably a competitor. But otherwise, there's some upper bound on that. So you have to think about, what does it mean when you're at your upper bound for your customer? Is the expectation that you're going to fail all new requests? Are you going to queue them? And then what if you pick queuing, how long will you queue, and how does your customer get notified if you weren't able to service that request? And does the customer expect to retry it, and how do they know when to come retry it? Because honestly, if you don't tell them when, they're just going to hammer the crap out of you. Actually, they're probably going to hammer the crap out of you either way, because they just don't care about you. It's your responsibility. You signed up to deliver the service. Sorry. Okay? So that's really a lot about what's going on in terms of scaling. For what it would mean on top of Kubernetes, you have a couple options. Within a cluster, you can leverage horizontal pod scaling, which is to say, for an existing set of infrastructure, I want to run more pods across all of that infrastructure, maybe driving up utilization of your existing infrastructure. If you have affinity, if you've cordoned off things like, I need my Prometheus or my database to run on some NVMe or SSDs over here, and you don't want the rest of your workload over there, then the benefit of using something like a cluster autoscaler is then when you reach some notion of capacity there, you can then just scale up those components as necessary, right? So that happens at an application level, Kubernetes notion application level, to say I have n number of pods, that's time for me to scale up in this node pool. Which is different than an ambiguous, I'm using too much CPU or I'm using too much memory kind of behavior, where you don't really know what's going on in the environment. Maybe you're just actually operationally having a problem. And then the last thing I'll say that's important when it's time to do service delivery on top of Kubernetes is to remember your TAL and not panic. Anybody Hitchhiker's Guide to the Galaxy? All right, good, thank you. All right, 42. So also breathe, which some people would tell me I should do more often in my talks. So really, it's going to be okay. Figure out how you're going to be able to schedule and stage your deployments and how you want to build your application. But you're going to be fine at the end of the day. There's always other companies looking to hire if something goes terribly, terribly wrong. So this is a little morbid, I know, but. Here's some resource slides, fmproject.io, if you want to see the nitty-gritty of of the open source pieces of FM Project, and then a link, and I don't know why that didn't linkify, to the use method as well. I'm TJ Fontaine at Twitter, and I have a couple minutes of Q&A if somebody wants to ask me questions. Otherwise, I'll be milling around over here, breathing and drinking water. Somebody? Yeah.
So the statement that I keep hearing when it comes to serverless or functions as a service, and I want to just validate with you if this is true or not.
Okay. I'm the authority, clearly.
is the value really only that I can scale to 0 as compared to using Kubernetes and some of the other niceties? And once I do not require to get to 0 because I have enough customers, I should move out of serverless and I would be more cost competitive if I use Kubernetes.
So the question, as I hear it, is the primary value that serverless allows you to not pay anything when you're not doing anything. But if I have enough scale and I'm doing enough work at all times that I might get better utilization or bang for my buck if I were running on my own infrastructure where I was managing bin packing. The answer is going to be maybe. It really depends, right? On what your work streams look like. I'm hesitant to say one way or another, but obviously, if you've already gotten to the point where you've defined your application or workload well enough to live in a serverless ecosystem, I'm going to say congratulations, because it doesn't really matter at that point where you run. You've got a nice, well-defined thing that can scale basically wherever you want, which is kind of the benefit of that platform, or the benefit of the programming paradigm. So if you've gotten to that point where serverless is your bag, and you're like, yes, and all you have to worry about is how much it costs for the wallet, then you're killing it, man. So congratulations. But without knowing more about the specifics, I would be reluctant to say one way or another. What's up?
You said uptime versus ease of use, right? What's the going towards zero, right? In the serverless, what does uptime look like?
I want to set context a bit more. So the question was, what is ease of use versus uptime? In that particular context, I was talking about the package management solution and upgrading their software. So ease of use to me was one command and all components of my service have been updated in kind of one lockstep, moving together. Even though Kubernetes may be doing rolling deployments behind the scenes, if something fails, I need to be able to roll back. So between the one command, fire and forget, and everything updates, and the need for uptime, I may end up splitting all these things apart, depending on what my concerns are. Does that make sense? So that's the part that I'm talking about. Cool. Sweet. All right, guys, I'm going to give it back to Bob and let him usher in the next segment. And for now, I will see you guys in the networking section. Woo!
We have a really cool panel coming up, so I'll invite my panelists to come on up and we'll kind of get situated here. Let's see, so Blaze, and you sit there. I'm going to sit here. Let's see what we got. Lee actually make it? Yeah. Okay. Well, we'll leave the spot open for him later. Lee Calcode from SolarWinds actually is going to have a plane cancellation at the last minute, so we may actually. Okay. So, super excited about this panel. It's the subject near and dear to my heart. I've been working in DevOps and cloud native for like the last 10 years. But early in my career, I worked a lot in the AI expert systems area on the way back machine. So I've been always thinking about AI expert systems and now machine learning and now deep learning and where all that's going. And starting to apply a lot of these new technologies around Kubernetes, cloud native, and containers and serverless, and the rest of open sources out there to these new big data, AI, ML challenges. So I'd like each of the panelists to introduce themselves and then maybe talk about what they're doing and maybe how they're using cloud native and some of the challenges that they have in the system. Let's start there. So why don't you pass down one of the microphones? Yeah, we're going to share. And put it on there. There we go. Awesome.
Can y'all hear me? All right.
Yes.
Yeah, my name is Blaze Berry. I'm a senior software engineer with Walmart Technology. We just opened an office down the street on 4th in Colorado. So I'm working there primarily kind of one foot in the machine learning door and one foot in the back-end software engineering door. Background was in physics and neuroscience. Like many physicists, made the transition to machine learning a couple of years ago. And right now, focused on a large-scale text analytics project, looking at some of Walmart's internal email data, trying to find ways to extract business insights out of that data in an automated fashion. So happy to be here.
Thanks, Blaze. Yeah.
Hi, I'm Andrew Busey. I'm the head of product and founder of Conversible. We have a SaaS platform for enabling companies to build automated experiences across messaging and chat and voice platforms like Alexa and Facebook Messenger. So mostly big companies like Pizza Hut and Disney and Procter & Gamble. So pretty broad spectrum of stuff. Previously, been an entrepreneur in Austin for a really long time. I was co-founder of Capital Factory. Also ran a big group in St. Austin where we dealt with many big data and massive scale problems with, we had a 7 million daily active user day right on AWS. So.
Howdy, my name is Dustin Kirkland. I'm a product manager at Google Cloud, based here in Austin. I'm responsible for the Kubernetes worker nodes in GKE and Kubernetes as an open source project for Google as well. For the 10 years prior to that, I just joined Google about 3 months ago. For the 10 years prior to that, I worked at Canonical and helped build Ubuntu as an operating system. So, and IBM before that. In terms of what I'm working on now, it's a bit tricky. None of the products that I'm working directly on our public information yet, but next week is Google Next, where there's quite a bit of excitement coming out about some things we're working on.
Hello, my name is Rob Hirschfeld. This might be disadvantage. And if you follow me on Twitter, I'm Zehicle Online. I am the co-founder and CEO of a startup called RackN, where we specialize in physical infrastructure automation, so creating a cloud-like experience with bare metal. And in that, I've been deeply involved in the OpenStack communities, lately in the Kubernetes communities. Right now, we're getting very interested in edge technologies and edge infrastructure, so putting IT infrastructure in colo and in more remote locations on sites and things like that. And as a consequence of that, I've been co-hosting a podcast called The Latest Shiny, where we actually dive pretty deeply into this L8ISTSH9Y. If you're interested in these topics, we cover them in some really significant depth. So.
This is what happens to latecomers. So my name is Lee Calcote. I'm slightly more flustered than normal. My flight was just canceled a few minutes ago, so looks like I'm going to have a late evening. So very pleased to be joined with some esteemed colleagues here. I've been in Austin coming up on a decade now. I'm still working on my YALs, my drawl. Known Karthik and a few of the, yeah. Yeah, we do live in the country. We do have some animals. I did just spill water on myself a minute ago as well. I tend to follow probably my inner geek. My full-time focus is over at SolarWinds. Outside of that, I wear a number of hats in the community and get to engage folks in the community. So I wear a hat as a Docker captain, as a CNCF ambassador. Just finished up a short book with O'Reilly on service mesh. Maybe we'll talk about service mesh. Yeah, I tend to make myself a nuisance wherever I go, I guess.
Great. Thanks, Lee. Maybe it's a chance to also talk about maybe the tech stack you're working on, and across the board, cloud native in particular, but other things, technologies you might be using in your current environment, and just to kind of relate it back to what we've heard already, and also other stuff. So and we're thinking of how to put all these things together over time.
Yeah, absolutely. So I can't claim to be a Kubernetes expert by any means. I haven't really used it much at all. Big Docker user though. We use Docker for deploying our microservices for the back end of our application. But we also use Docker on the data science practice, really for standardizing the environments that our data scientists are using, being sure that what they're doing locally and what they're doing on a server, regardless of what operating system or distribution, there's an entity recreating their results problem, and found a lot of value in that. In terms of development stack right now, lots of Python on the machine learning side, lots of Node.js on the back end, and lots of Python in the Spark sense. We do a lot of distributed computing, just given the size of some of the data that we work on.
Yeah, there's some Node.js guys around the
Yes, yeah, I heard. I'm going to bring that.
Okay, cool.
We're all on AWS. Our core stuff is in Go. We do a lot of stuff in Python as well, because we do a lot of machine learning stuff. We do use Kubernetes, but I'm not really the guy that does that, so I don't know everything about the details. We do a lot of microservices work on the internal side of our system design, but we also do a lot of interfacing across different clouds. So we do a lot of stuff, for example, with Dialogflow, which is running on GCP, and we use Lex on AWS, partially because our customers span a bunch of different platforms. So we have customers that are building on Google, that they're building on our platform for Google Assistant and Alexa. So that means we have to use different pieces. Also, Facebook is a customer of ours, so we use WinAI for them. So we use a lot of different NLP services. So one of the best things I think about, from our perspective and a purely business perspective, is that things like really sophisticated NLP problems, in some cases, we're able to use things that Google and Amazon and Oracle probably will offer to do things that we wouldn't be able to do if we had to do the first-party research to build those, because these companies have spent probably tens, maybe hundreds of millions of dollars of R&D, and now they basically commoditize that R&D, and that allows us to build much more powerful features and functionality into our products than we probably otherwise be able to do.
So if I'm writing code for myself for fun, I like a lot of Python and Go. But the thing about being a product manager at Google is that they really don't let you write much code anymore. And it's great because I'm surrounded by dozens, hundreds of engineers who are 1,000 times better developers than I ever thought I was. So I've got a great team around me, and the tool set that is used to build Kubernetes is used all throughout Google. My tool set is really data, essentially, as a product manager, and having access to tremendous amounts of data, how workloads work, all of course whitened and anonymized, but I'm really blown away by how much data filters into making good product decisions, good UI, good UX, when something's working and when something's broken, and how to improve that. And that's really the most important tool in my tool set.
You guys, TensorFlow, Kubeflow, you seen some activity there?
Absolutely. Ironically, I was just here at Capital Factory exactly a week ago, where we were at a machine learning meetup and talking to a bunch of people about Kubeflow.
Yep.
I've got a peer product manager, David Bronchek, who was in town from Seattle to talk Kubeflow to this group and a bunch of customers around Austin.
Cool. That's cool. So our platform is Go. We do most of our work in Golang, very lightweight, awesome product, REST APIs, React for the UX experience. And then, while it might sound funny for somebody who focuses on physical infrastructure on premises, actually we have a pretty significant Lambda infrastructure driving the UX experience on the back end. So even though we believe in on-premises infrastructure, we do a lot to automate that, we also take advantage of serverless, and all the Amazon services that are available from that perspective, because it's the right way to build applications.
Did you get that on premises? Premises?
The right way to build applications?
The right way to say it?
Speaking of enunciation, Arunchik, and see, I just want to say Aaronchik, and I never said that to his face, so note taken. Yeah, very good. Yeah. Coop cuddle to you as well. Coop CTL. That was my alarm for the flight that is no longer with us. You will, yeah. You're in luck. You will suffer more of me as the evening goes on. Great. Gosh, where to start? So at SolarWinds, primarily focused on monitoring and management. That's kind of the SolarWinds focus. Lots of on-prem, kind of hybrid focus. We are being recorded, but I would say that we've got beginnings of a nascent set of offerings around those that are running cloud-native workloads. Maybe nascent isn't the right way of describing it. I would say not as much as we would like. The offerings that are there are strong, particularly around distributed tracing. So there are, now I don't recollect if I just said this, there's about 50-ish products. So a lot of SaaS, a lot of on-prem. Of the projects of my function and where I focus on technology strategy, we end up doing some innovation projects. We also end up being the group to create some new products. We're currently working on a SaaS offering, and internal to it is my inner geek maybe got the best of me here, but it's about half of the CNCF projects are implicated in its development. And so some that are maybe less popular than others. We can talk about those. Open Policy Agent. There's some. I just mentioned, I think, distributed tracing, but open tracing. Helm is in there. The Prometheus gets used. We also do lots of integrations there. We're going to do a service mesh deployment. What do you know? So there's some Envoy implicated in there. So just kind of a list of those things. We end up spending a lot of time in that space. And so,
Cool. maybe we could talk a little about some of the deeper challenges and some of the top challenges you guys are facing, maybe as you see the industry facing. Also, maybe what's really important and what's kind of overhyped. Because we have a lot of buzzwords here with deep learning and machine learning and cloud native. So trying to cut through and see kind of where the challenges are and kind of what's also said.
Well, I think working on the machine learning side as an engineer, LinkedIn can be your worst enemy. Before I was here, I was out in Palo Alto, and sometimes I felt like it had an especially bad case of LinkedIn article comes out and everybody thinks that the bounds of possibility have been pushed, and oftentimes it's been the product of an exciting conversation, but more hypothetical. So I think oftentimes really taking a mature look at where the science is, what the opportunities are for delivering value in the near term is what actually ends up producing a viable product and a viable business case. In terms of challenges on the cloud side, I think one of the things that keeps getting brought up in areas that I've worked is just some of the security concerns. There's always going to be a bit of nerves at work when you're pushing data or you're pushing some of your business logic outside of your own system. And I'm sure we could sit here and have a pretty great debate about whether those concerns are warranted. But in certain business use cases, I think oftentimes people want to really walk the careful end of that line, and I get that. So I think finding where that give and take needs to be addressed is oftentimes one of the biggest things.
Yeah, I would echo that, so I'll start there. GDPR has been a really unpleasant topic of conversation. I think that probably our friends in Europe had really good intentions with that, but it's really not great if you're a startup that has any customers outside of the United States. And that's a lot of overhead, so we had to spend a lot of time really meshing engineering and product management together to understand the flow of data around microservices and what retention looked like of all that data, and making sure.
It's not much better being in one of the biggest companies in the world either.
Yeah, but you can afford lots of lawyers. Yeah. Probably shouldn't talk about that. But yeah, it's not fun paying lawyers when you're trying to grow a business, especially to address something that is somewhat of an edge case in most actual scenarios. But when you sell to large customers, you have to show that you understand it and that you're meeting those criteria. So it's probably been the biggest challenge, because the architecture is, I think, a little bit different than we imagine as product people, as we dig into all the core details of what's happening with that data. So that's been a challenge. I also echo AI is often considered magic when we talk to people, which is interesting when another place where startups and big companies come into conflict a little bit. Big companies are very good at marketing things in very, let's call it, aspirational ways, whereas we have to actually deliver things pretty quickly. So that's been a big challenge. I think it's in some ways it's great to see for example Google on TensorFlow and Dialogflow, making those services both free in the case of TensorFlow and cheap in the case of Dialogflow as a service. So there's a balance there. I think that's evolved in since we first started using AWS, whatever that was, 15 years ago. So it's mostly been a good progression, but there's definitely a lot of challenges.
So I think one of the hard questions we're struggling with, particularly around the Kubernetes community, is around go fast or go slow, and iterate on features or iterate on stability. Coming from the Ubuntu world, we try to balance that with the 6-month release cycle. We released in Ubuntu every 6 months, and then every 2 years, we released an LTS, long-term support. And the 6-month cycles would be supported for 9 months, which was just long enough so that you could always be on the edge and sort of roll forward. And then the LTSs were supported for 5 years plus 2 years of extended life support, so 7 years in total. And you know, it's somewhat tempting to try and mirror something like that in Kubernetes itself. From one perspective, you've got applications that work, and once they work, you just want to run that on a platform that's always up and gets its security updates, but has no chance of regressions or breaking features. On the other hand, that doesn't feel very cloud native, and it's not what you get or what you expect out of a SaaS, a software as a service. You know, you're expecting your Gmail and your Drive and your YouTube or whatever to just be developed in the background or fixed in the background. And Kubernetes in some ways feels like a SaaS, especially when you're using a GKE or an Amazon, Microsoft, or Oracle equivalent to that. But then when you want to take that and run that on-prem, or you want to take that and you want to do something else with it, I think it's kind of an open question. It's something that I'm spending a lot of time thinking about working.
Dustin, let me ask you this: of the Kubernetes distros and the plethora that are out there, I don't know if you've had a chance to get a sense of how some of those distros have approached that particular problem in terms of.
Sure. I mean, I'm quite familiar with them from a competitive analysis standpoint. And you know, on one side of the equation, you've got Red Hat OpenShift with 5-10 years of support, very very long, but very slow to pick up and adopt new features. It's many releases behind bleeding edge. On the other side, you've got you know, rolling with every single Kubernetes release, which comes out every 3 months, so twice as frequent as Ubuntu, and you know, generally are really high quality at it. The teams across the industry, not just at Google but everywhere, have done a fantastic job in driving quality. But there are regressions, and some pretty famous regressions along the way.
I would actually take what you said, boil it down to 2 words: technical debt. Technical debt is not just, do I have bugs in my code that I haven't fixed yet? Operational headaches, it's problems with getting things ported, right? We love to run in with, you know, cloud native, shiny, you know, wands and say, you are cloud native, you are cloud native. And the reality is that migrating applications to cloud native is hard. We have a tendency to bifurcate IT and leave a whole bunch of things in the dust. We work very hard, it's one of our mantras, to work with legacy infrastructure, to not say you have to change your infrastructure to use our product. That is an unbelievably hard statement, because it's much easier to walk in and say, this is great, just write it for Kubernetes and everything's going to be good. When you turn around and try and use Kubernetes on premises, it becomes, I'm saying it now very deliberately for you, when you do that, it becomes, well, do I have all the infrastructure components, right? Do I have all the services I need? Do I have all the pieces and parts? How does it fit my infrastructure? And the learning bar is much higher from that perspective.
I tend to describe it, I think that's good. I tend to describe it as a set of layers or strata. And the further down in the stack you go, the less frequent you want change, right? If you take it all the way to the bottom, you don't really want the microcode on your processors changing, and yet we got to fix vector meltdown with micro right? But above that, you know, you've got firmware, you've got you know, your bootloader and your kernel and your operating system. Each layer up you go, I think you can tolerate like one more level of change frequency. But when you start at the top and your application is a Docker image, you want to be able to rev that constantly. Push that to GitHub or Docker Hub or whatever registry, and you want that rolled out immediately. But as soon as you go one layer below, you want ultimate stability, and it's just the nature of being a software developer.
Yeah, I'm going to disagree with that 100%. So here's the problem, and what we see is that people are building software for the cloud native infrastructure, makes the implicit assumption that you are going to delete, destroy, and replace, you're not going to patch and upgrade. And if you are building infrastructures today, physical, on premises, I don't care what it is, and you are not assuming that you're going to have to manage that entire stack all the way down to the firmware, because we're seeing firmware bugs like Spectre and Meltdown, where you have to be able to automatically apply and patch and fix your systems. You have to treat even physical machines as immutable infrastructure, where you can take them offline, you can patch and re-image and go back. It's not a question of saying don't make those changes, it's a question of rethinking your whole operational paradigm and being able to say, I'm going to treat this as a frequently updated piece, automating it so that it doesn't take you any time, so that if you have a BIOS refresh, it just floats through your infrastructure. Those technologies and techniques are critical. And if you don't want to own it, that's fine. Just move to the cloud. That is a perfectly legitimate thing. If you are in a place where you need data locality, or you need control, or you need machine learning, we'll get to some of the infrastructure components for that, where it's a cost concern, you need to be thinking about your infrastructure in a much more immutable cloud-centric way. Just because it's physical here doesn't mean you can't make it cloud-enabled or cloud infrastructure, cloud-native. It's a mentality and an operational approach. It's not a place.
I'm going to go ahead and roll up my sleeves here. All right. So let's get into what's going to happen. One of us has got some poop kickers on, the other one's got some pretty shiny boots. I don't know. I'm not sure. But actually, interestingly, to riff off of that, if you were to lay out kind of a spectrum of maybe of speed. So to the extent that folks are doing serverless things, that they would maybe benefit from lesser concerns. It's not that operations aren't a concern, but there are fewer things to touch and be responsible for. I actually think that of what Dustin and Rob were saying is pretty complementary. I think Dustin was saying that you anticipate as you build layers of things, and you're building toward that application to ultimately offer functionality, and that's sort of why we're all here, I expect, for those services, for that application. It's something of a North Star that you would, some of those things that are lower in the stack that you want stability out of, and actually to Rob's point, like you want, not only you want stability out of it, but to the extent that an issue does arise, you'd hopefully have learned maybe from some cloud native things and be able to address those in a declarative way, in an immutable way. I don't know if you can do that necessarily with physical hardware as much as you can do it with firmware.
I think we're saying the word "you" a lot here, and there's a lot of different "yous" in the audience, because there's the you who's a Ruby developer, or a Node.js person who wrote that app and wants that deployed and running infinitely, and does not want to deal with anything below that stack. As Rob said, there's public clouds for that. In some of the larger companies in the world, you run private infrastructure that mirrors what a public cloud would do. But there's a very different you here who racks and stacks hardware. And the concept of taking that hardware and making that hardware addressable as a cloud-native unit is a beautiful concept. There's no doubt about that. But unless you're in a startup, there's probably not, it's not your responsibility to write the app and provision the operating system and rack and stack the hardware and update the firmware and ensure security compliance. But some people are responsible for the full stack, right?
I wrote this stuff a long time ago. So, I mean, at Zynga, we tried to switch to C Cloud, which was not a pleasant experience. It got reversed. So, yeah, even at that scale, sometimes it's not worth it to rack and stack your hardware.
I think one of the things that's worth talking about from a cloud native perspective is stable and doesn't change are not the same thing. We have a tendency to say, my infrastructure is stable, meaning it's reliable and robust and I can count on it, and saying, well, that means I haven't changed it. That IT bus left in the 90s, and building robust IT infrastructure, whether you're in the cloud or on premises, is not about not changing it, getting it right, and then locking it up. It's about building a way to automate, fix, patch, and keep it updated. That's what makes infrastructure robust, not locking it behind a glass door and hoping nothing happens.
So this brings up kind of an interesting question for me, which is, as I see so many advantages of using public cloud, just as a developer, it makes things so much easier and you can iterate so much faster. And we've seen so many people kind of move to that model just because it does allow you to get things done quicker. But it does then start to kind of create this disparity in kind of the talent pool that can build Node.js applications or Ruby applications, and the talent pool that can actually stand up the physical infrastructure and get down into some of the lower level layers. I mean, me personally, there's a point in the computing stack where I just become totally worthless. And that does, when you start to focus it down to just a couple of big cloud providers, do you see any kind of risks associated with kind of shrinking, where that kind of talent can go work? Is there a scary bottleneck there for now?
It doesn't scare me at all. There's plenty of hard problems to be solved, for sure. I went to college and got a degree in basically hardware engineering, and while what I learned was how to design circuits and boards, I've never used that. I went straight to software, and I've seen over 18 years of my career just move all over the spectrum. Part of that has been open source. I've been a Linux and open source developer for a very long time, and there's just no shortage of hard and interesting problems to me. No matter where that technology goes, it doesn't scare me a bit.
Actually, I think that the shortage, and maybe one of back to the original question, the challenge that I expect many of us face, but I'll just speak for myself, and that's finding the talent. Actually, finding talent that knows any of these layers of the spectrum. There's lots of folks out there, but generally and broadly speaking, there's a shortage, particularly as we move fairly quickly in this the cloud area, the cloud era, the open source era, this way of doing it in immutable infrastructure. It can be, those things have only been around for so long, only been popular for so long. The tools have only been made available for so long. Some of the projects that we're speaking about, some of their biggest challenges are making it simple. I think we have a tendency, and this is tried and true, and I think we can point to a lot of examples, or at least I can in the career that I've had at Cisco and Seagate and now SolarWinds. As engineers, we tend to make things pretty complicated because that's what we do. That's the fun thing. That's what's challenging. Making some of this easy and broadly applicable, making it simple, making powerful things simple. Apple does that very well.
I think the place where it's impacted me the most, I've been doing startups for a long time, and I remember when we had physical machine pillows. Before that, we had physical machines in our office, which was horrible. I think that there's been a material change probably in the last 10 or 15 years in how you can start companies, and obviously this is a much more of an infrastructure-focused panel in some ways, but as someone who focuses more on pure application development, the availability of many very sophisticated and very powerful cloud platforms from these big companies that are highly supported, constantly advanced, and heavily maintained and very competitive, which is a great price, has freed us up from you have a limited amount of capital in a startup, which means you're limited to who you can hire. So instead of hiring a much larger percentage of DevOps or pure physical infrastructure people, any pure DevOps right now or any pure physical infrastructure, probably won't ever have that for a while. But it's helped us build much more sophisticated products because we don't have to think about those things, because we have other people thinking about those things and we don't have to pay them that much. Kind of abstractly. So I think that's like the biggest benefit from our side, and that maybe shifts somewhat for talent development and certainly talent acquisition. But I suspect the big cloud providers are sucking up all the people who have the skills on the stack.
I'll say that having been in Austin now for over 18 years, I've really seen the talent pool in this city grow and grow and grow tremendously. There's always been sort of those anchor companies that are now quite traditional enterprises, the IBMs and the Dells. But now with cloud presence from Oracle, Amazon, Google, Facebook, I'm sure I'll leave out plenty of them here, Microsoft, others, and then the healthy ecosystem of startups, with startups, many of those being focused on very forward-leaning, cloud-native, open source, containerized. The spotlight that some of the conferences recently over the last couple of years has put on the city of Austin has been tremendous. KubeCon, DockerCon, OpenStack a couple of times, and so forth. I think that's good for all of us here, everyone that wants to stay here. I know a lot of my colleagues that have moved from the Bay Area to Austin and are loving this town and see what they do with it. And then the one other thing I'll say that is really I'm going to steal this from a former colleague of mine, Simon Wardley, put this on Twitter recently. He says that the race is on for the first two-person startup to build $1 billion company using a function as a service. I mean, literally the right idea and the right stack. There's just so much of that. Now, those two people will probably pay tens or hundreds of millions of dollars to run that function as a service somewhere. But if it's the right idea and it's the right app, it only takes a couple of people to put that together.
So let me maybe wrap up here. Maybe want to talk about what are some of the most interesting or untapped opportunities, what's most exciting, maybe future, looking ahead to the future, be it edge, core, be it health, be it science, or you can wing it from there. It's kind of up to you how you want to look at it.
Yeah, I'm a big entertainment geek. I
Yeah.
love film, love TV, and really just love a really intense visual experience. And I think that with all of the development in deep learning, especially image processing, computer vision, what's really exciting these days is some of the generative networks that are actually creating novel images based on training set. And what really gets me kind of going in the cloud native world is just being able to scale to so many resources, such huge data sets, so many computers to actually process all of that. I'm really intrigued to see what happens in the entertainment industry in terms of just kind of building some of the special effects, some of the visual layers that we're going to get to experience. I think it's not talked about as much as I kind of would have expected, but I think in the next 5-10 years we're going to see some really cool stuff, and I'm super excited.
I think TPUs are going to turn out to be one of the biggest breakthroughs in recent history, and I think once TPUs get rolled out to the cloud, that's going to change what people can do with machine learning and deep reinforcement learning and a couple of other categories of AI, including vision, in ways that we don't comprehend now. And I assume that it's highly likely that we enter some new phase of Moore's Law based on TPU acceleration that will have some impacts over the next 5 to 10 years that are huge.
Blockchain, because we haven't said blockchain yet today. And you have to
One more buzzword. Bingo!
We can talk about that, but I'm going to go real boring here because I think it's underutilized and untapped. But VM virtual machines are, I think, on their way out and being replaced largely by containers. But the containers that most of us talk about tend to be Docker containers, process containers, which are perfect for newly developed applications. The stuff that I write in Golang is fine to just statically compile that and start from scratch container. But there's a ton of other workloads that are running on physical machines or running in virtual machines that aren't yet ready to be fully containerized to a process container. But there is another class of containers called system containers. And there's a ton of workloads that have the opportunity to take advantage of the performance and the density benefits of containerization and some of the orchestration benefits of containerization that aren't quite there and ready to become an application or process container. I've spent most of the last decade working on the Linux containers in the LexD project at Canonical, which lives on at Canonical. It's a fantastic technology. It's not nearly as interesting as the visual stimulation or TPU, but there's a huge amount of efficiency to be gained by containerizing old and legacy applications.
I agree with you there. I think people underestimate innovations coming through on infrastructure. When I look into the future on these things, I get very excited about edge infrastructure, and I've been really investigating through podcasts into why that is such an amazing thing. It actually combines a lot of the things that we've talked about. The interesting thing about getting edge infrastructure right means that we can suddenly put powerful computational ability into devices that aren't able to have powerful computation, which might sound really strange. So if I have a low latency connection to a data center infrastructure that's in my wireless hop, a 5G wireless hop, then I can put a supercomputer in my watch. I can put a supercomputer in an eyeglass rim because it's really network connected devices. And I don't need the batteries, I don't need expensive processors. We're in a position where getting edge infrastructure right and putting TPUs, GPUs, processors distributed in our environment in microseconds away from our use of those transforms the applications we build in ways that we haven't anticipated yet. Because we're used to, this is going to sound crazy, our phones have battery and CPU limitations that we're not going to solve because of physics. But if we solve it by moving that processor into a place where it's nearby, then all of a sudden our phones could be as thin as a sheet of OLEDs. That's incredibly powerful. It's transformative.
I'll maybe resonate a few of those things. Yeah, I think that to what Rob has said, I think that the way that we do a lot of things is going to change the way that we shop. I mean, obviously that's changed and continues to change. How many of you guys, I don't even know what they're called, have those little AWS buttons you press at home that reorders, like the dash? Yeah. Anybody? Who has those? All right. Yeah. Anybody find themselves with like a stockpile of hand soap or anything? Anyway, I think to Dustin's point, even though it may not be sexy, when you consider the massive amount of workloads that are running in virtual machines, or that are running on physical servers that are waiting to be virtualized, and that aren't necessarily worth taking through a rewrite into a cloud-native architecture. Well, it's not sexy. It's a massive problem to solve, massive efficiency to bring. That's interesting. I think I mentioned service mesh earlier, which is maybe why we hit the bingo with blockchain. I think that for me, just kind of from an infrastructure focus, I think. A lot of folks, there's many more to come, but a lot of people have been playing with containers for the last 5 years, and certainly kind of predating Docker's popularization and simplification of it. And then, a couple of years into that, it turns out they've got lots and lots of containers running, and so then they need some orchestration, and then maybe some of us call that choreography at some point, just to differentiate. And then turns out a bit later on, they've got very little visibility or some amount of infrastructure-centric visibility into where their applications are, how they're distributed, which end is the front, which is the tail, and how the traffic is flowing. And and I think service mesh comes in maybe at layer 5, if you will. Kind of helps decouple developers from operators. Maybe helps bring services as a first-class thing as a first-class construct in your infrastructure, such that you can provide declarative control over it, and it's just a piece of the puzzle, I think, as we step towards visibility, control, security around services that are now distributed.
Thanks, Lee. I want to wrap up here and say thanks to the panel for great job. We got some great demos back here. We have the Innovation Hub guys in the corner. So we have Startup Accelerator team, JD. We have 2 really cool demos over here on the serverless and Kubernetes side, and some of the demos running. So feel free to reach out, talk to all of us. We'll be hanging out here for a while. And thank you all for coming.
Hey, and thanks to Bob and Oracle for hosting. It's been an excellent
Yeah.
They can understand how on-premise works. Not